Yeah, thanks everyone for coming to the session. Happy to have you here. So my name is Michael. I'm Sustainability Innovation Lead at Celonis. So Celonis does many things, but my focus is on how do we embed sustainability metrics into how we organize and run supply chains. So not just sustainability as a silo, but really making it part of the way we analyze and improve the business. And I think because we have quite a small group here today, I think it's nice to make things a bit more interactive, and maybe I'll even adjust. So can you maybe share a bit in what you would hope to learn or what kind of input you're looking for? Is there any like, is it just a general understanding of how it works, how to apply it, or are there some specific areas or domains? Because of course, agility, resilience, and sustainability are very big topics. So
Yeah, we look at Celonis how we can help in reporting CO2 reductions, based on the data mining from the system. So this CO2 reductions, I think, are
okay. In transportation or in procurement, scope 3 end to end. Okay, very good. And anyone else?
Transportation data mining as well.
Yeah. Okay.
Yeah, what I'm looking to learn is what are some of the use cases that you can help solve for in like pharma domain, where there's increasingly a lot of reliance on external manufacturing. So manufacturing of medicines and vaccines with CMOs, and in an environment where a lot of that is being done manually, there's no standard documented processes. How can Celonis help map the process, but then also, how can it help drive agility and drive value continuously once it is implemented?
Okay, so that's all about reliability as well then. Yeah. Anyone else have any input on what's most interesting to learn? Okay. But let me get started. I think these are some really good points. And also, I think if you at some point want to ask a question, just put your hand up, and you can always take a break as well, because most important here, of course, is that we all learn something and share knowledge. So if something is particularly relevant or applicable, please provide some input as well. So for those of you who don't know Celonis, Celonis is a software company founded in 2011 from Munich. Now it has offices in many, many places around the world. I'm based in the Netherlands, but we're here in London. We have, I think, 7 or so in the US, and Asia, a few as well. We started with a focus on process mining, which is really about an analytical transparency into your operations. And now we've evolved to talk more about process intelligence. And the difference between the two is mainly that process mining is understanding how do things work, and process intelligence is combining it with recommendations, with more operational improvements that can also be carried out by the platform. So going from analytical to really operational. And this is something that's brought a lot of success in terms of value, in projects, in helping companies improve operations. And for me, the fundamental reason why is that we focus on processes. Every company is built up on processes, and these run horizontal through the operations. But all of the analytics and the KPIs and the departments are organized vertically. So you have all these vertical silos that have their own KPIs, their own priorities, but actually the work goes horizontal, touching each other. And so when you have this friction of horizontal and vertical, it creates challenges in a multinational context. And that's really where we, by connecting that data, can see a lot of things happening. And within supply chain specifically, we've always focused a lot on the 3 main priorities of the working capital, service levels in terms of resilience or on-time delivery, customer satisfaction, and cost. And these are the 3 main priorities that exist for the supply chain domains, and all have their different challenges and their different focus areas. But what we've also seen is that just by itself, sustainability becomes an additional priority, because if you work in supply chain, it turns out that the most of a company's impact is upstream or downstream in the supply chain. It's from your suppliers, from your transportation carriers, from your waste, or how your products are used. So for every company that now has the need to report and reduce their emissions, supply chain is a really fundamental focus, and also where many of the biggest challenges are in sustainability. And how that manifests itself is, in sustainability, you have the regulatory pressure, the need for CSRD, there's CBAM, CS-DDD, a lot of different acronyms that if you're in the field, you probably dream these acronyms, but it's a bit difficult if you're not as familiar. But also getting data from suppliers and value chain partners is a big focus in sustainability. So what do our suppliers do? Do they use green energy in their factories? How do they design their products to use better materials? A lot of these core insights are missing, which make it harder to actually decarbonize and reduce emissions in your own supply chain goals. And customers are also more and more asking for, what is your product carbon footprint? Like, can you share this information with us? And this really comes on top of all these existing challenges, which are about delivery date changes, rejections, cancellations, inventory that gets written off, backlogs, or inventory that stays there too long. So due to things that, due to suboptimal planning. And so for us, we've really focused a lot on this supply chain perspective in the last years, and now increasingly more and more on sustainability. And that's really where I focus my work, is how do we apply the software, how do we bring it in, measure properly, and also help prioritize. And the most important thing there is we also have to always bear in mind, if you focus on sustainability, we cannot then disrupt the core operations. Like, yes, we reduce emissions by using road freight instead of air freight, but if we miss our on-time delivery goals, then that's going to do more harm to the business. So having this trade-off and this balancing perspective is really important for making that progress. And what we see is, again, we're talking about processes, and processes are the key. This is where we survey that processes are a core leverage point. You know, these things happen at scale, the processes in the organization, and that means that if we improve and use them as the focus area, we can also deliver on many of these challenges and these priorities. And what that means in terms of how a company operates, I already explained it a little bit, but on the left you have, we design a process, our procurement or finance or production, inventory, distribution, it doesn't matter, but we define steps, maybe with post-its, with mapping, with all these standard approaches. We also define what common deviations are, so we see things can go not as expected. In the second square, there might be some other alternatives. But what really happens in that third block is that there are many different challenges. When you're working with many different product lines, divisions, countries, all these things add complexity. And then the systems that are set up are not really good at giving the transparency into where and why things are not going as they should, which means you have that complexity of the process. And supply chain is, of course, the most complex of all, because we're connecting these together, where how we work with our customers can be affected by how we buy from our suppliers due to the knock-on effects of availabilities and everything like that. And so the way we approach this from like a data architecture and technology lens is that we first start with, okay, you have the physical supply chain, you have the stock of the supplier, transit, materials, production, distribution, and delivered. And what we see is then companies have defined, of course, processes. This is what you said on top. You have procurement, transport, all the different functions that exist within an organization are set up to facilitate that flow on the bottom. And these are likewise supported by ERP systems. And this can be from the suppliers. They have an ERP system where they plan how they fulfill your goods. You have the factory ERP, you have trade systems, warehouse management, transportation, and CRMs. There are a lot of different systems that track progress across the supply chain. But as we were saying in the past, or I was explaining, these things are all connected, but these systems are not connected. And that's a core problem. These give these vertical snapshots into how it's going at one specific area, but it's not showing you the interdependencies. It's not showing you where optimizing your procurement might harm your production schedules, for example. And these relationships, when they're not visible, they cannot be discussed, and it's hard to collaborate on solutions. And that's really where we focus on applying our technology. So we apply the process tracking using system data. So not with subjective, human-defined maps or guides, but really just extracting raw data and visualizing it from the systems. and creating we call it a bit of like a subway map or spaghetti bowl. There's many different variations in analogies that are used, but essentially creating that tracking and visibility of how it actually runs today, considering these upstream and downstream dependencies, so that when you analyze, you actually have the full information visibility. You can see unknown unknowns, you can see dependencies, and you can also create consensus and alignment around the problem so that you can all work together constructively on a solution. And that's what the technology can support from a visibility perspective. And so I'll go into a few examples and I'll just show it actually what it looks like in the software, because I think that always makes things really tangible. But I also want to talk a bit about what we do for sustainability specifically, because this is my day-to-day, where we use this same data models, the same connections. So every company we work with that already looks at their procurement, production, distribution, we use that same data automatically extracted on a daily or hourly basis to track what is being purchased, from which country, which suppliers, which addresses do we ship to, what is the bill of materials, how do materials relate to each other, essentially that full map. And we use that as the foundation to apply methodologies for sustainability. So there, if you know you're buying all the certain quantities from this supplier of this material in this country, then by mapping the emission factors, you can create this automated tracking of what are my emissions in procurement. Or for transportation, if you have the addresses and you apply a distance calculation algorithm, you get distance and emissions calculated automatically as well every day. And that's really what we try to focus on, is using existing platforms, existing synergies where you can focus on both agility and resilience, and also apply that same approach for really high quality and also automated measurement of sustainability, so that, yes, you can report, but it's also then good enough to be able to have governance of performance internally and reduce emissions as well. And this means that we often also work with supplier data. So where you say, we need to know that our suppliers' due diligence is sufficient, we want to know what are the carbon footprints of the products they sell us, and so you also integrate methodologies to collect that data via partners like EcoVadis and Integrity Next, but also with a number of other methodologies. So being kind of flexible. And the result is really you create a dashboard or an app or something where we enable for reporting, setting targets, attributing, getting business adoption, and then being able to reduce emissions. And I want to highlight a few examples here. We have some logos at the bottom, just to kind of explain how that works. Like Dur, for example, is a manufacturing company in Germany. They have more than 300,000 unique products that they buy from their suppliers. And mapping the emissions for scope 3.1 for the procurement side is a lot of work. They estimated it would cost them 15 FTE to do so if they did it manually. But by applying a logic with this AI suggestions for text, you have your emissions factor database, you have your master data. If you suggest the matches with the AI and you train it, you can save a lot of time. It doesn't automate everything 100%. AI is not that good yet, but it does give huge productivity savings in how you can be detailed, but also effective in building that up. Another one is ABB, where they focus on the transportation emissions of, they have more than 36 ERPs in their total landscape, but all of them are connected to Celonis. So we have the full visibility, and so we can have automated calculation of the distance and emissions of every shipment every day. And they see that they use air freight because of unavailabilities of products, of customer lead times, and they can see, okay, when we use air freight, what was the lead time we had, and can we actually find opportunities to reduce air freight, either by asking the customer, can you take a bit longer, or by just identifying waste and delays in our processes to actually make that possible. So that's another good example there of combining the business data of lead times, which we measure, as well as the emissions of different modes of transport, and I'll show that in a bit. And the last one, and they're not on this slide actually, is Zumtobel. They are a lighting manufacturing company, and they really wanted to engage with their suppliers at scale. And their goal was, we don't just want a small silo team working on sustainability, we want it to be something that's fundamental for our category managers. And so they had 70 people. They went from 2 to 70 people who are onboarded onto these platforms and using it for sending requests. Each category manager has their prioritized overview. They can press buttons, it triggers APIs, and they have the prioritization and the adoption that the software provides them. And there are a lot more examples like this, but this shows a bit of the focus in being efficient with reporting, in getting business adoption, so it's not a small siloed topic, but is really carried by many people within the organization who can all work towards your goals, and then also analyzing performance to try and reduce. And so this is, I think, nice to show, but I want to also give a visual demo so you have a better understanding as well and see in practice what it looks like in the system. So if I change... So I'll go through a few steps. I think I'll try look at the perspective from several different types of individual. We have a supply chain leader who would want to have top-down tracking of what is performance and where do we improve. And they see a control tower like this, where we can track the service levels. So what is our on-time delivery? Are we making our customers happy? We have the inventory. What is the turnover rate? How good are goods moving? And can we improve in that area? And then we also have the emissions, where we want to track this within the same data and the same views, and also focus on how we can improve that in the future. And so this supply chain leader will then have the high-level view, but of course they can't go into the details. It's too much data, too much work, but they can see alerts of where, based on previous performance, there are issues detected that create gaps. And that can be that transfer stock is not good enough, that our emissions are higher than they were previously, or that our delivery dates of our purchase orders keep changing, that this is something that shows there's a lack of stability. And so the supply chain leader can then ask the analyst who's really deep in the data and can dive in, can you please investigate what our performance is? Can you diagnose and come back with some recommendations on how we can fix this? And so the next step is for the analyst, and here we see the process, and I want to just spend a little bit of time on this too, because this is the fundamental enabler of the technology, where we track then all the steps that happen for every data object. In this case, it's the sales order. We see it's created, 2 hours later it's confirmed, then the goods are received by we know that we have the goods in our warehouse so we can ship them, we create the delivery, we send the goods, and we create the invoice for the customer. So this is one process of one object, which is our sales order. But we see already here that there are deviations, like we have to postpone our delivery date, we have to, we have credit blocks due to financial conditions, and we change our prices, so there's master data issues that slow us down and cost productivity, or we have delivery blocks. And all of these are things you see in your KPIs, but it's not easy to know why are they happening. Like, what is the root cause and what can we do to fix it? And that's where the real benefit of connecting this data together helps, because for in this case, when we have our sales orders, we need to create a corresponding purchase order to make sure we have all the goods at hand. And by linking these objects, we can connect the data together to see how these processes are connected. So when we have our sales order, we then have a purchase order created, which is sent, and then we see a requested PO that the date is delayed, and then we have a goods receipt here. So it arrives in our warehouse after we purchased it from the supplier. And in this example, it takes an average of 16 days after we set the delivery block and we have the goods arrived in our warehouse, which shows how procurement and delays from our suppliers can have a fundamental impact on our on-time delivery for our customers. In this case, when we're doing this moving of stock that we do not, of course, need to produce and change ourselves. And this shows this interrelatedness of separate domains where it would just not be visible with standard BI tools, with things where you just see a snapshot or a silo. And this is just one example and part of the picture, but you have invoices from the supplier, the customer, you have more activities, you have delivery items. And what we do is we build up this full map, and at some point it starts becoming harder and harder to track. But this is essentially how we track the movement of all these goods and products through the systems by tracking each object individually, the sequences, how they're related, and then connecting that to the performance and seeing where and why do things work well. So our analyst sees this and says, okay, that's great, I've dived deep. I see we have delivery blocks, we have delays from our supplier, and then we can focus on this as one of the priorities to improve our customer satisfaction. But they also want to have a broader view of the supply chain. And so this is a different lens of how you can look at it when you have the purchase orders and the sales orders connected. You also create the map of, we see suppliers, we have our goods flowing to our factories. In this example, we often then also connect the bill of materials as something when you want to connect components to the finished goods. But you can create this traceability then of, we have goods purchase orders here, and then we have production orders in the factory and sales orders moving downstream and deliveries all the way to the customer. So creating that base, that tracking, and this data model is a type of foundation, a platform where you can say we want to look at, what is our inventory turnover rate, for example? Where is it doing the best out of all these? Or what is the service levels of, also the intercompany where we are delivering on time? And for us on sustainability, you can also track the emissions, where you have emissions tracking across the different stages. And so one example here of then looking into this, we see that it's quite clear. In this case, if you look at a certain step that your network of the warehouses to the customer, there are multiple steps involved. And this might also not always be necessary, because when inventory supply-demand planning is not optimized, there can be intercompany transfers, which are also extra shipments, which cost time and money and emissions that are not needed. And so here I want to focus a bit on the emissions aspect and transportation, and how we then also help with that calculation. Because we're seeing here, that we have potentially additional steps. But what is the real impact of that from a sustainability perspective? And that's where we have a partner who we plug in an API from, where we say we're going from Rotterdam to Slough. We have air freight and we have emissions and distance. And we can do this direct calculation of the route, where we see, we start off in Rotterdam. We predict that we use Schiphol Airport, which is the closest freight airport. And we have a flight which goes to the UK, and then a truck which goes to Slough. And this is something which the ABB example uses, and many of our other customers like Pfizer, for example, as well. And this is especially relevant when you outsource transportation to shipping carriers and providers. Like, sometimes they provide data, but it's not always reliable or trustworthy. So this means you can, even when it's outsourced, use internal data to have this continuous calculation across the whole business. And also compare, here we have 1.3 kilograms for that weight, but what would it be if we used sea, for example? So we see then the alternative and how the emissions is much, much lower, and rail as well, going via the, under the sea. And in that way, being able to have this quantitative analysis, where you can then say, looking at, our specific routes, that's applied for every shipment, but here we have Sydney to Frankfurt, where we have air freight and sea freight. What if we changed our transportation modes? Like, what would the emissions difference be? Here we're looking at air, sea, and rail, but we also look at electric trucks versus diesel trucks, other types of fueled things, so you can really provide this quantitative trade-off. And then also connect it to your on-time delivery requirements. Like, yes, we're using air from Sydney to Frankfurt, but we know that going by sea takes quite a long time, so it's just not always avoidable. And you need to validate that if you would want to make any changes in your supply chain. And so this kind of shows a bit of the data foundation. It shows how we can connect these things together and provide analytics. But we also then always want to make things a bit operational as well. And in this case, I'll show an example of transportation load consolidation. We apply this to many of the things we diagnose and take actions to, but then someone who's in the business, who's working with shipments on a daily basis, you can also provide recommendations for them, saying with a high priority, with a cost and lead times, we see that for this shipment, there are actually consolidation potentials. So we have 2 shipments when there could be 1. You provide with the calculation, this message to someone. You can also send an email or put it into another system if they don't want to log into this tool. And you can then accept this recommendation, and that would then update it in the source system, in the ERP or the transportation management system, and kind of make that bridge from, yes, we detected what's happening on a global strategic basis, we know what happens generally, but we also diagnose that certain issues are reoccurring. And when we can detect them on a daily basis, we can also suggest recommendations and provide them to the person that can take that action. And in this example, it's about consolidating shipments, but it's often also about expediting shipments, about changing modes of transport, or also on the procurement side about how you engage with your suppliers. And so that really shows how you can work on that business user adoption. And showing one last example briefly, we also do the same for emissions in procurement. So if your procurement users are saying, hey, we want to get primary data from our suppliers, we want them to tell, you can also create this view of saying, look, as a category manager, I was logging in again. As a category manager, you can request data from your suppliers, you can select which ones you want to send, and you send them a survey or a questionnaire that they can fill in to provide you with real data and information. And the goal here then as well on the category manager side that you can provide them with a workflow where you prioritize, these are your suppliers, this is where we have information, and we want you to use your relationships, your leverage essentially that you can use to improve our data quality and our performance. And when we talk about such a big story as the whole supply chain, we have resilience and things like that, it's hard to show all these different examples, but these are just a few different use cases at different departments across the chain that can focus on both cost reduction or customer satisfaction, but also specifically sustainability and how we work in procurement and in that area. And that's what I wanted to show in terms of the software, in where we have an executive user can see a control tower, an analyst, really the IT expert, can go into the details, and then a transportation planner can see what, can take recommendations and can take actions as well. And just to summarize that briefly, what we showed is you have the systems which we connect to, data platforms, you connect them all together to create that model. You can then create this process intelligence view of the maps, the analytics, and connect also sustainability data sources via your own ones or ones that we have with partnerships. There's a lot of different options out there. And then you can focus on both the supply chain performance as well as the sustainability performance. And what I showed here is network visibility of the supply chain, load consolidation, but there's also things like the material allocation, unshipped orders, planning parameters, consignment stocks, and many, many more that can all focus on how to improve. And on sustainability as well, I focused on shipping emissions, showed a little bit of the scope 3.1, but you can also use that data to calculate your product carbon footprint, for example, because you have the whole base there, or other things like CBAM, due diligence, EU deforestation, like all of these involve working with value chain partners, and this data provides a foundation to have that approach set up. So I hope this is given some insights, and I know we'll have some time for Q&A at the end. I'll just share, we do this really with a focus on trying to help with achieving certain goals. So on the sustainability side, AB InBev also had a good example where they optimized the effectiveness of their routing and first-time right of deliveries. They even connected GPS data to their shipments and integrated it into the model, and that gave them a lot of distance saved with both the cost and emissions benefit. Duren ABB I already talked about, where they have a lot of focus on both procurement and transportation, but we have many, many more companies we work with that also focus on on-time delivery, for example, Reckitt, where we also do the transportation emissions with them and building up that model, and then also more focus on working capital or inventory reduction. So this is essentially what I wanted to share, and part of it is sustainability is quite a new thing, You know, when you talk about optimizing, if I go here, about optimizing on-time delivery or working capital, these KPIs have existed for decades. But from a performance management perspective, sustainability KPIs are completely new. So we find it very important to put it in the context of a step-by-step plan. So we call it a sustainability transformation. But essentially, what you need to do is think sequentially and define how do I deliver value across each of those stages. So one of them is getting reliable numbers. You need to have internal governance as well as external reporting. And that's just the step one. You know, you can't renovate your kitchen if you haven't built the house yet, essentially. You need the good data that you can trust. Step two is getting adoption. So like we said, with category managers who can work with suppliers or transportation planners who can see what the emissions are, you need to think, okay, we have many different countries, and each country should take some responsibility for the emissions performance of their domain. And you provide them with tracking dashboards, with analytics that they can use to also identify and work on improvements. And this is very important for success because, in my experience, many sustainability teams, it's like 3 people in a silo, and they engage with the business, they try to get support, but it's very difficult. You know, when you try to change how a multinational operates, but you have just a few people affecting everyone. And the last stages are really about actually implementing those measures and also engaging with stakeholders like customers. And we see some companies we work with really saying, we see that the market is changing, and by being a leader in this, we can protect our revenue, our relationships, make sure that, you know, yes, now it's reporting, but in 3 years it will be different, and we want to be ahead of the curve and make sure that it works that way. So we always recommend following this step-by-step process, having clear expectation management and ownership and success criteria across each stage, and also sharing some learnings here. There are some challenges we see quite often around strategic uncertainty, data challenges, and business adoption. With strategic uncertainty, we see that, you know, companies are talking about 2050 goals. Like, it's a lot of planning ahead, and there's a real tendency or temptation that this is like a waterfall approach where you're saying, okay, which steps do we have to take to get to 2030, 2050, making extensive PowerPoints, but it's a big challenge. And here this IT, agile, you know, iterative, think big, start small approach has been very effective for us, where we do hackathons, for example, or pilots or small things, you know, minimize the risk and the cost, just try it out and see what the results are and use that to learn and get clarity. And same with data, we know it's never going to be perfect, but we just have to be pragmatic and say, what is good enough to deliver the value in this current stage of our maturity? And then when we go to the next stage, what is good enough for that stage, and build it up over time. Really prioritize and embrace the motto, you know, you need to use your data to improve your data, and that's an important step there. And we've seen as well that when it comes to thinking further than just the next reporting deadline, this integrated business and sustainability metrics of lead times and shipping emissions, for example, or supplier emissions and cost and reliability, creating these shared dashboards can really help with creating value beyond compliance. And we also see some cases like with AB InBev, where efficiency can provide a win-win, where you reduce cost and reduce emissions. And when you find these examples, they're very powerful for demonstrating that, you know, we reduced air freight, we cut out waste and inventory, we improved the performance, and that also is a first step on what we want to do when it comes to emissions and sustainability improvement. Okay, so thank you for listening, everyone. It's really good to have you here, and we do have time for questions, so thanks, and ending the presentation and handing also the floor for any topics. Yes?
So what's the average lead time from the discussion? Hi. So what's the average lead time from the discovery to deployment? Just average.
Is this from, like,
Implementation perspective.
completely, like, there's no data, nothing? So we work a lot. It depends if there's already Celonis, like, implemented in supply chain or not. the thing that's interesting is like getting the data into the system and having the visibility takes a few days, but then validating it can take weeks and maybe a couple months. If we would start from zero and go to full implementation, I think it depends a bit on which topics we focus on, but it might be a few weeks for the first pilot and getting results and showing the value, and then maybe a few months in the validation and making sure that we get the ownership, the adoption, and scaling it up in the organization. But sometimes we have very fast ones that do literally take weeks, or there are very complex ones, like when you work with the bill of materials and planning related to that, then it can take definitely 4 to 6 months or something. But definitely also for sustainability, when we work with a lot with companies that also already use Celonis, and I think some of you do in the room, we have a wide adoption, then it can take a few days to set up a measurement of emissions or things like that, and then a few weeks to validate it for reporting purposes.
I've got another one.
Okay.
So that's on the CBAM. You mentioned it's the shipping. It was titled under shipping, I saw.
Yeah.
Shipping something. Shipping related anyways. So my question is, do you also extend it to installations or not?
So for CBAM, we have a standardized solution for that specifically. And that's really focused on using the also customs data from the internal systems and procurement data and supplier surveys and creating the report that the EU needs. So it's kind of focusing on all the data collection, adoption by customs managers, and then creating the template. And we apply it for the full scope of what a company needs to report for. We would, I'm not sure which industry you're in, but we would see which activities fall into that. Can we just take it automatically from your system, or is there maybe still some stuff in Excel we have to use? And but yeah, I didn't talk about CBAM today, but this approach we have with sending surveys to the suppliers that I showed, we have the same approach for CBAM with a questionnaire and videos to explain to them how and why, also in Chinese or other languages. So that's one separate standalone module we have that we can add on. Yes.
Yes, hello. Very good presentation. Thank you. I know the tool and I use that. I think it's a very good tool. The challenges which we face was related to data quality. You mentioned that. What I would expect, honestly, Celonis to do a little bit more and better is maybe to help organizations in cleaning the data and somehow. I think data will never be perfect. We need to work with the data which is 70-80% accurate. Mm-hmm. So how we can really get a little bit more flexibility from this tool and help, on working with the data which is not perfect. That's one thing. And the second thing is related to it. Many organizations work on a different ERP systems where you have, we have SAP, you have JD, you have Oracle, and so on. When you grow a big organization, you grow through acquisitions. Often you keep the, underlying systems in place. And again, where we face the challenge with Celonis is how to get the consistent data from different underlying platforms. I don't know if you are working on some solutions, but I'm curious to know.
Yeah.
Thank you.
Those are great questions. So the second one, we created innovations in our platform and the way we structure our data models. And this gets quite technical at this point, but we call it object-centric. So instead of just using the terms from the ERP, like SAP has table names, JDE, we create a generic structure and then translations from different systems. So you can unify multiple systems in an easier way. And then once you build on top of that, you don't have to worry about the system language differences anymore. So this is something to solve that exact problem of different types of ERPs and you have to harmonize it. Then the idea is you only do that once, and then you have the translation of, a purchase order weight from JDE and SAP should flow into the same object. And then on top of that, you can build apps agnostically or use cases or dashboards, and you don't have that issue anymore. So that's one part. On the second part, we also, the first one, the data quality, we on the one hand try to just be pragmatic short term, like use business rules or shortcuts and say we want to deliver a result first. But we often also work with master data cockpits. So two of the logos I showed on the slide are Hitachi Energy and Syngenta. That's energy industry and farming, pesticides, fertilizers. And they, for both production planning and for sustainability, they have master data cockpits which flag missing values, outliers, and its signals where the data quality issues are, and then it can be corrected by a user. And I think this signaling and prioritizing and helping improve is something we can help a lot with. I do think there's more potential for Celonis and maybe in the future to develop really smart algorithms that say we fix it all automatically. I think we're not there yet, but this tracking, detecting, prioritizing, and helping people fix it is something we do quite often today as well. And if there are smart algorithms on the market, we can plug them into the solution, but we don't have them ourselves yet. Okay? Are there any more questions? Then I would like to thank you all for listening in, also providing the questions, and hope you have a good rest of the conference.